Okay. I think this keyboard is faulty. That's a problem. Okay, let's hope it doesn't flake out on us. Let's try this. Okay. That's working. All right. So far, so good. Okay, how does that look?
Kind of small.
Oh, okay, sorry. Well, this is as big as I can do it, unfortunately. This
That
is,
looks fine.
yeah. So the good thing is at least it's working today.
Yeah.
So I can use my Apple, my pencil here. And, we can I can write notes and then I can upload them on ELC and then people on the other side can see this. So I think it's going to be better today. But there's something wrong with this keyboard because I noticed that if I mess with it a little bit, the mouse goes out. So definitely going to have to look at it. Fix that keyboard. Let's see. I can do that. Looks pretty good. And then I can do this. Look at this. And I can do that. And I can go to this. Okay. Now it's much better than, because what I can do now is I can scroll up. See, I can scroll back down. So I don't have to keep on erasing. That's the major advantage to this. All right, that looks a lot better. So did you try it all, looking at the video at all?
Oh, I was going to do that for, later today.
Oh, okay, great.
Yeah.
Yeah, let me know. I'll ask the class too, but let me know if it works on Kaltura. Oh, you can try it now.
Yes.
Yeah. Because I can't see it from my end. I could see it on Kaltura, but I can't see if you guys can see it. So that's all right. There we go. Hello, Reese, are you there?
I am. How are you?
Great. We can
Good.
hear you very well. Can you see the screen?
I can. It says Mass 3300 in the date.
Great. Okay, so hopefully everything's going to work well today.
DeAndre.
You may have seen me.
Good, so the volume looks like it's good on the other end too. Good. It's working really well now.
Okay,
Okay, so I have it hooked up and everything.
so I did want to run through the monitor. Is that what it was?
Well, it was weird because, okay, so what happens with this keyboard, I've noticed, is that sometimes the mouse kind of goes out. And also sometimes this might go out too. And I
Maybe
have
we
to-
just need to replace the keyboard.
Right, so I'm thinking maybe it's just a keyboard, so you may want to,
Well, last time we were plugging here, so,
yeah, so I worked with it on Friday and Saturday. I got everything to work on that one.
yeah, I'll swap the keyboard out.
Okay, and then hopefully everything will be good.
Yeah. Let me see if I can do it.
Oh, no, well, okay,
Are you starting now? How
Yeah.
much time do I have?
well, 10 minutes,
Oh, yeah.
all right, okay. Okay, I'm gonna try to swap the keyboard out. Hopefully that'll solve the problem. And it won't go out or anything, so.
Hey, actually, I'll get everything ready.
Yeah.
What time is this over? I'll just do it.
Oh, yeah, good. So hopefully everything will be okay. So we're done at 1:30.
1:30. I'll put a note on my.
Okay.
Come back.
Okay, thanks a lot, Jerry. So did you guys watch on Friday at all?
Yeah, I was on Zoom on Friday.
Okay.
It was pretty good. The only issue I'd say was probably the volume.
Okay. So maybe I'll try to stand closer this time to the mic.
Yeah, that should work.
The advantage with this one over here. Hang on. Is that I don't have to erase.
Yeah.
You know?
Oh, yeah. That's all.
So it's going to be, I think it'll be much better.
Yeah.
So if I need to refer back to things, I can kind of go up and down.
You got the iPad to work now?
Right, you got the iPad to work now.
Nice.
And then, and so, see, there it goes again. Okay, so here's what I think we have to do. We have to do that. And then we have to go back in. And hopefully that will reconnect it. Okay, there we go. Yeah, I was working on this on Friday. So we think the problem is the keyboard on here,
Really?
that, because the mouse goes out sometimes too. And in the other room, it actually works.
Really?
Yeah, so that was a culprit right here. I think it's a keyboard. So hopefully we can get that taken care of. Jerry's gonna do it after the class. Hopefully things will be smooth. I may have to keep plugging it in and out today. So,
A lot of trial and error.
right. Hey, how's it going?
Good, how are you?
Good.
Can't find out what to access the video. Can't find out where to access the video.
Oh, it should be in Katura. So I think all the students have Katura. Once class starts, let me ask people if they were able to do it. Because what happens is, Katura uploads the Zoom video from this class, and then I could publish it on Katura. And that should give you guys access to the video. So. All right. Cross our fingers.
Well,
That's what I'm doing. It's pretty nice.
but I decided early on that I was going to graduate in 4 years, so got to finish it on.
As well, they already suffered up to this point.
Okay, let's see, we got 7 participants on the other end here.
Just run in. Which one's Richard?
All right.
Way up.
Just every single. This week, I've since myself basically it's been getting a certain amount of stuff. But we can still cover. Always give us the same thing. I got lazy to drive.
It's lazy stuff. Photos on it.
Yeah, lazy.
That's, you teach that.
Maybe. Tell me, that's a good teacher.
Yeah.
Like it's, other than that, just a lot of work. Is,
Really?
yeah, fail.
Yeah, we gotta pick one of those bricks aside.
You have to do that leadership first. Like I said,
We have to do it.
that's like another thing that makes you off of competition. So,
There's some little things to keep up. In the PE class, that's like something.
Yeah. I'll have to check Bill's Andrew's class. Just
Make sure they're just out.
holes.
Yeah. Just nice.
You get the-
Okay, is it, let me ask you guys, is it better to have the lights off? To see? Yes.
I'm good with
Doesn't
it.
matter.
I think this is better.
Is it better? Good. Okay, so let me do a sound check first. So can everyone hear me on, who's on Zoom?
Yep.
Great, and we could hear you too, so that's really good. Okay. All right, so I worked for about an hour or so. On Friday, I actually checked out the other room and things worked well. On this room, I found out that the iPad goes on and off sometimes. So I alerted the computer specialist, and he's going to change the keyboard. So he thinks the problem is the keyboard. And so if I have to stop and replug in the iPad, please be patient. Nothing's wrong. I mean, should work. Okay, so so the first thing is, let's get back in here. Okay. So the first thing I'd like to do is now go over the syllabus. So can everyone see the syllabus on the other end?
Yep.
I can see it, yeah.
Yes.
Okay, good. So let me just kind of review this. I didn't have a chance to do this on Friday. So again, I'm Dr. Nakano. I welcome you to this class in person and via Zoom. So I have an office upstairs on the 6th floor, and my phone number is listed. And I can be contacted via email too. And so once we get things set up, I'll actually try to get office hours going. And so I was thinking of having office hours Monday and Wednesday from 11 to 12 o'clock, sort of by Zoom appointment, meaning that if there are people who are interested in having an office hour that day, I will actually have a Zoom session, okay? The text is Linear Algebra and Its Applications by Lele and McDonald, the 5th edition. And what I've done is I've laid out a course schedule for the entire semester, okay? And so I've done this so that you know what homework assignments or what homework problems are going to be due. So as I've mentioned on Friday, all homework is written. There's no computerized homework in this class. Okay? I really want to emphasize the skills of writing things down, writing your answers out completely, so that it prepares you both for your mathematical thinking and also for the tests too. Okay, so the first homework assignment is 1.1, 1.2, and 1.3. And that will be due the Wednesday after this week. So that'll be September 2nd. Right? So what I'll do is I'm actually meeting with the grader on Tuesday, and then we're going to try to set up OneNote for submission. But in the meantime, just go ahead and do your homework on paper. Okay, write things out, do it on paper, because either you'll turn it into me by hand for the first one, or else you'll just scan it in and make a PDF of it. So you're not wasting your time by doing things on paper. Okay, so I would start your homework and start the homework problems. And again, if you can ask me sort of like after class if you have problems on the homework or anything like that. I'm happy to answer that. Okay, let me get back in. Okay, so this kind of, and there are two midterms. There's one in week 6. Move up. Okay. And there's also one in week 11, as you can see. Here we go. Oh, come on, move up. All right. Okay, so let me mention a little bit about the grading policy. So we have, the homework is worth 20%. It's worth quite a bit in this class. It's worth basically one midterm. And then we have 2 midterms, regular midterms are worth 20% apiece, and the finals worth 40%, and it's cumulative. Okay. Okay, I haven't decided how the final is going to go. The midterms will, as long as we stay open, the midterms will be in class midterms. Okay. The final, I'm not quite sure. I know that it can be problematic because of proctoring and things. So one option is maybe to have it for a certain amount of time and have an open book or something like that. We'll figure it out as we go along. Okay. Let's see, can we move up at all? There we go. Come on. Kind of slow here. At least it works. Okay, so again, I highly recommend that you look over your book before coming to class. It really helps in order to learn the material. And, you know, the success in your class will depend on your ability to read outside of class. Okay, and again, the homework will be due on the following Wednesday. So the homework for the previous week will be due the following Wednesday. And then I don't think I have to remind you the academic honesty policy and withdrawals and what else? And that's it for now. Okay, great. Any questions on this? Go ahead.
So that's scheduled throughout the semester. Is that kind of tentative, or is it pretty solidified in the problems that'll be given every week?
It's pretty solidified.
Okay.
So I guess, you know, my preference is I really hate when like professors like do out problems like piecemeal, like, you know, little by little. Okay, so the problems here are for the entire semester. Okay, so that means, you know, there is no sort of, if you happen to miss class or something, you don't miss any of the problems that are given. They're right here. Okay, any other questions? I've actually taught this class before, so I mean, you know, this has been kind of a reasonable level for people. I mean, it'll give you, it's enough work and it's enough practice too, I hope. Okay. All right, great. So let's continue on. All right, now we hope this works. Okay, so so let me start off the class again, and let me review just a little bit so that we don't sort of go in cold. All right, so what were we talking about last time? We were talking about the vector interpretation. Hold on for a second. Let me see if I can do this. Got new glasses. Let's see if this works. Oh, much better. Hopefully I'll write straighter this way. Okay, so we have the vector interpretation of a system of equations. So recall that we have V, and this is a vector. Let's say maybe it looks like V1 and V2, the coordinates. And we can sort of represent the vector in 2 space like this. Here's X and here's Y. And the coordinates are V1 and V2. Okay? And what can we do with vectors? We can add them. We can add vectors by just adding their components. and then we can multiply by scalars.
So,
Question? Okay. All right. So let me give you an example where we can actually switch a system of equations. So this is an example from last time. So we have x plus y equals 10, and we had 2x plus y equal to 6. All right. So this is a system of equations. It's two equations and two unknowns. So we can actually translate this into vector notation by sort of pulling the x out and making this 1, 2. We have the y here, and this is 1, 1. And this is equal to 10, 6. Okay? Great. All right, and so 10, 6, we're asking whether it could be written as a linear combination of the two vectors 1, 2, and 1, 1. All right, let's now move on to a new example. And let's again look at x plus y equals 10, and 2x plus 2y equals 20. Okay, I can move things up. What I'll try to do is I'll try to post the notes on ELC. So I posted the last notes on ELC, and now with the iPad, I can actually post these notes on ELC too. All right, now let's write this in terms of vector notation. So how can we do that? So if I take the x out, what should I get here? Okay. And the y, what should I get? Good. And that's equal to 10, 20. All right. And now what I can do is I can combine the 1, 2s together, right? So I have x plus y times 1, 2 is equal to 10, 20. All right. So if I want, I could call this t. And so the idea is if I stretch the vector 1, 2, can I actually get the vector 10, 20? So let me just draw a little picture for you here. So 1 here, and here's, let's say, 2. So I have this vector here. And can I actually get the vector 10, 20 by stretching it? Yes or no? Yeah. Okay, so this works for t equals 10, right? So if I stretch, make t be 10, I can get the vector 10, 20 here. Right? So the question is, so we have solutions to this equation, or the system of equations, and as we've seen, there are infinitely many solutions. Ooh, okay, jumped on that. So there are infinitely many solutions. The Palm did it. Okay, let's try it again. So if I set t equals 10, then I can take all x, y for which this is true. So as long as x and y satisfy x plus y equals 10, then I have a solution. Okay, great. All right, now let's quickly do one example, and I'll run through this fairly quickly because you've seen this before. So x plus y equals 10, and x, darn it. Let's see, let me move this all the way up here. X plus y equals 20 here. All right, let's stare at this just for a moment. So I have a system of equations. There are two equations, there are two unknowns. What are the solutions going to be for this? We have one solution, infinitely many, or no solutions?
No solutions.
No solutions, very good. All right, so now let's see how we can do this using the vector method. So I have x, all right, again, it's just x 1, 1 plus y of 1, 1 is equal to 10, 20. Okay, so again, we can combine the x and y. And so I have x plus y times 1, 1 is equal to 10, 20. All right, so, you can also set this equal to t. Okay. So is there any t which makes this work? No. Okay, so there's no t which makes this work. So that implies that there's no solution. Okay, any questions on this? All right. All right, so let me make a definition. So a system of equations, so I'm going to move this up. So a system of equations, linear equations, is called singular. Okay, so let me underline this. Okay. If it has no solutions or infinitely many solutions. Okay. All right. So we've seen examples of this. So for example, this case over here is singular. And then this case over here was also singular too. All right. Okay, so I gave you examples of systems of equations which are singular, either no solution or infinitely many solutions. Okay, are there any questions at this point before we go to higher dimensions? All right. Okay, now we get to do the more exciting stuff. All right, so the next topic is called Gaussian elimination. So Gaussian elimination turns out to be a very important algorithm. It's an algorithm that could be implemented on a computer. And when it's implemented on a computer, it could actually run in polynomial time. So it's a very, very efficient algorithm. So what I'd like to do is I'd like to present the algorithm today. And the idea is we want to actually solve m by n systems of equations. Oh, yuck. Rats. No. This palm detection is not working very well today. Systems of equations. I think I have to keep my palm tipped. Okay, so we're going to solve m by n systems of equations. So what is m? So m is the number of equations. And n is the number of unknowns or number of variables. All right, so I think the best way to illustrate Gaussian elimination is through an example. So what I'm going to do is I'm going to give you an example of a system of equations, and what we'll do is we'll actually solve this using the method. And I think once you get the hang of the method, then you'll be able to use this over and over and over again. This is sort of our bread and butter for the class. Okay. So here's the idea. So the idea is you start with the system of equations. Now let me just express it in terms of a matrix. And then I'll just put some dots over here. Okay, you'll see what this means in a second. And the idea is you want to transform a general matrix in a triangular form, upper triangular form. So you want to transform this into something which looks like this, maybe, which is triangular with zeros down here, and then you could have some stuff over here too. Okay? So let me start with an example of how to do this, and we'll do lots of examples in this class. All right, so I'll start by actually giving you a system of equations. So let's start by doing this. So this is 2x plus y plus z is 1. And I have 4x plus y is equal to minus 2. And minus 2x plus 2y plus z is equal to 7. Okay, so here's a system of equations. There are how many equations? 3. How many unknowns? Okay, so this is a 3 by 3 system of equations. All right, so I don't want to carry around the x, y, and z all over the place. So I want to make it into a more compact form. So here's what I do. So I make a matrix like this, and I put the coefficients 2, 1, 1, and I put the 1 up here like this, okay? And then I take 4, 1, 0, and I have minus 2 over here, and I have minus 2, 2, 1, and 7. Okay, is everyone good so far with this? All right, so we've transformed this system of equations into a more compact matrix form. All right, so the idea is we want to start knocking things out. All right, so what we want to do is we want to put a 0 down here in this position, and we want to put a 0 down here in that position. So the way it works is we're allowed to use this element, and this is called a pivot. Okay, so as long as that element is non-zero, we're in good shape. So in order to knock out the 4, what I'm going to do is I'm going to multiply the first row. So let me just say it this way. I'm going to multiply, let me see, what's the best way to do this? Okay, I'm going to move this over a little bit. Okay, so 2, 1, 1, and a 1, okay? So I'm going to take minus 2 times equation 1 plus equation 2, and I'm going to insert this in the second row. Okay? So notice if we do that, we're going to take -2, and we're getting the first row then will be -2, -2, sorry, -2, -4, -2, -2, -1, -2, and then add it, okay? So let's see what happens when we do this. Okay, so I'm going to multiply this one by -2. So let me put a -2 just up here to just kind of remind us that we're multiplying the whole thing by -2. Okay, -2 times the first row, add it to the second row, and then put it in the second row. Okay, so what do we get for the second row? What's the first thing we get?
0.
0, good. What is the second thing we get? -1, good. Next one? Great. Okay, next one? -2 times 1 plus -2.
-4.
Oh yeah, -4. Very good. Okay. All right. Very good. Does everyone see how we did that? Okay, so we used the pivot in order to knock out something just below. All right. Okay, so now what we're going to do is we're going to do it to get rid of this one down here. Okay. So what do we have to do? Well, we just take equation 1 plus equation 3, and where do we stick it?
Third row.
Third row, very good. We do it in the third row. Okay, so up here, let's just put a little 1 up here. So kind of forget the -2, okay? So let's just add the first and third rows and then put it in row 3. Okay, so what do we get down here? We get 0, right? What's the next one? 1 plus 2 is what? 3. Next one? Good. Next one? 8. Very good. All right. We're almost there to get it in this sort of triangular form, right? Okay, so what do you think we do next?
We have to make the 3 into a 0.
That's right. So we're going to use this one as a pivot now. Okay, so that one's going to be the pivot. And so what we'll do is we'll do the same idea. So I'm going to multiply 3 times row 2, add it to row 3, and put it in the third row. So 3 times row 2 plus row 3, and put it in the third row. Okay, now in this process, I mean, you have to actually prove this, but it's not very hard, is that you're not changing the system of equations. This system that you're getting is equivalent to the one that you started out with. Okay, let's do that. Okay, so we keep the first 2 rows the same. 2, 1, 1, 1, 0, -1, -2, -4. And then we get 0, 0. What's the next term?
-4.
Good. Next one?
-4.
-4. All right. So we got this triangular form now, right? So we got it in this form over here. This form over here, which is desirable. All right. Now, let me ask you a question. Why do you think it's desirable to have it in this triangular form? Well, let's write the equations out. Okay, so we're going to write the equations out again. Okay, so here are the equations. Okay, so what do we get? We get 2x plus y plus z is 1 minus y, oh God, I did it again. this Palm thing. They got to do the next iPad design. Okay, so minus 2z is equal to minus 4. Okay? And finally, what's the last equation? Minus 4z is equal to minus 4. Okay, so this is equivalent to the equation we started out with. Okay, what's the advantage to having it in this form? Here, sorry. Sorry, what did you say? Yeah, it's simplified. So what can you do now? Right, so I can solve for z. Once I solve for z, what can I do? I can solve for y. Once I solve for y and z, what can I do? Okay, so that process is what's called back substitution. So now, apply, darn it. I'll try to figure out how to make this better. So now apply back substitution. Okay? All right. So what are we gonna do? We're gonna take minus 4z is minus 4. So z is what? 1. Good. So you maybe want to box the answer like this. And so we have minus y minus 2 times 1 is equal to minus 4. Okay. So that's minus y minus 2 is equal to minus 4. So that means that y is equal to what? 2, right? Okay. And then finally, 2x plus y plus z is 1. And now I can put in y and z. So that's 2x plus 2 plus 1 is equal to 1. 2x is equal to, 2x plus 3 is 1. 2x is equal to minus 2, right? So that means that x is equal to what? Negative 1. Okay? And if you put these back into the equation, you'll actually see that it works out. So let me write it a little bit more cleanly. So the solution, I don't know why it's, maybe I need to push it up further so it doesn't hit the bottom. Let me try that, okay? All right, let me try doing this, okay? So the solution, this looks better. I see the problem. The solution is x, y, z equals, okay, now I have to actually move it up again, minus 1, 2, and 1. Okay. All right, any questions on this? All right, so the nice thing, you know, when you think about it, you can do this if you have a million equations and, you know, 5 million unknowns. It turns out you can actually apply this algorithm to solve systems of equations, and that's how actually computers do this.
Good question.
Yeah.
Do you know the actual time complexity? Or?
Yeah, I think it's like in like n cubed or something like that. Yeah. You know, this is related actually to, if you do like theoretical computer science, it's related to the P versus NP problem.
Oh, okay.
Yeah. Yeah, it's really.
I was only asking because I did algorithms last semester, so it was the first time maybe exposed to this algorithm.
Oh, yes.
Yeah.
Yeah. I'll try to mention this a little bit more as we go along when we talk about determinants too. Okay. Other questions here or online? All right, so now let me show you what we need to do. So there's some times where we have to make some adjustments. And so we kind of have to use our head in order to make these adjustments. So let me show you another example. Oh, I did it again. I'm gonna have to push it all the way up. Sorry about that. Somehow this thing is very sensitive in certain areas. So what happens if, I did it again. All right. If a pivot is 0. Okay, so what could happen is you could start out by having a 0 pivot. And if you have a 0 pivot, there's not much you can do. You can't knock out the thing below it, right? So let me give you the example here. So we have y plus z is 20, and x plus y plus 3z is equal to 15, and 3x plus y plus 2z is equal to 10. All right. Now, normally, if you just put it in the matrix form, you would get 0, 1, 1 with the 20 here, and 1, 1, 3 with the 15, and 3, 1, 2 with the 10. Okay, so notice that in the top left-hand corner, we can't use the 0 to knock out the 1, right? So, all right, so what do you think we should do to solve this system of equations?
Change the order.
Right, so it's good. So if we change the order, does that change the solution at all? No. So let's change the order. Very good. So changing the order means changing the rows. So change the rows. Okay, so let me say this does not change the solution. Okay, so let's just make the second row the first. Okay, so 1, 1, 3, 15, and maybe 3, 1, 2, 10, 0, 1, 1, 20. Okay, all right, so now what I'll do is I'll use the 1 here as a pivot. Okay, so that'll be the pivot. All right, so what I'll do now is I'll move a little bit quicker through this. So what multiplier do we need for the first row to knock out the 3?
-3.
-3. So let's just put a -3 here. And again, we keep the first row the same. And we knock out the second row. So this will be a 0. Next thing is what? -3 times 1 plus 1 is what?
2. -2.
Or -2. And -2, right? What's the next one?
-1.
Is that right? I'm multiplying the -3 times the entire first row, adding it to the
7. Or -7.
-7. Very good. Okay, next one after that.
-35.
35.
35. Very good. You'll get good at arithmetic and multiplying things quickly after this. Okay. All right. Now let's keep the third row the same since we have a 0 here already. 0, 1, 1, right? 20 here. Okay. Great. All right. Let's see. Do I want to proceed? All right, and then you could just proceed from here. All right, if you want to multiply it by 1/2 and do this out, so you can sort of proceed. Yeah. So I won't necessarily finish this one off. I'll let you finish it off. Did it again. Let me push it up. Sorry. Okay. And I'll say just proceed. Okay, so you have plenty of This will be an exercise. Okay. So it basically proceeds in the same way. So here you want to multiply by maybe 1/2 here. Okay, and add the second row to the third row, put the result in the third row, get it in the triangular form, and then back substitute to solve the system. Okay, so any questions so far? Yeah, go ahead.
For that last step there, could you multiply either of those rows and then add them together?
Oh, yeah, you actually could.
Okay.
But, so a lot of times you want to have one. You know, that helps out to have a 1 there.
Yeah.
If I wanted to, I could switch those 2 rows again. So I get the 1 there, and yeah, I don't have to work with fractions.
Gotcha.
Okay.
Just making sure there weren't any weird little
Yeah.
rules in there.
Yeah, so the idea is if you multiply a row and add it to another row and then replace that row, then you don't change the system at all.
Okay.
Okay. Good. All right, so let's do another example. Okay, so let's do this. So this is x plus 2y minus 7z is 0. Minus 2x minus 3y plus 9z is equal to 4. And finally, minus 2y plus 10z is equal to minus 8. All right, so again, we have a system of equations. We want to solve this. So let's put this in a matrix form. Okay. So here we go. 1, 2, minus 7, 0. Okay, what's the next one? Minus 2, minus 3, 9, and a 4. And then finally 0, minus 2, 10, minus 8. Okay, everyone all right with this so far? All right, so we'll apply the Gaussian elimination procedure. So what do we want to do first? What do we want to do?
Is 1 the pivot point?
Multiply the top.
Right, so I want to use this as a pivot, and I want to knock out the 2. So I'm going to multiply the first row by 2, add it to the second row, and put it in the second row. Okay, so I keep the first row the same. And then I get a 0 here. What's the next term?
1,
1, good. Next one?
-5,
Yep, good. Next one?
4,
4. All right. Okay. All right, we're down to this stage. What do we do next?
Multiply the second equation by 2 and add it to the third equation.
Very good. So I get 1, 2, minus 7, 0, 0, 1, minus 5, 4. Okay, so now we have to do the work. 0. What's the next term? 2 times the second. 0. Okay, what's the next one?
0,
What is it? 0. Good. What's the next one?
0.
Aha. Interesting. We got a 0 row on the bottom. All right. So I'm going to throw this question out. What does this mean? Okay, so let me write this in terms of equations. So I got x plus 2y minus 7z is 0, and y minus 5z is 4. All right, so what's the system, or what are the solutions going to look like?
Is it going to be singular?
Well, the first equation is the equation of what? Well, I mean, if I take x plus 2y minus 7z equals 0, what does that look like in terms of a graph?
A plane.
A plane. Good. So you have one plane, and then you have another plane. And so you have two planes, and you want to know how they intersect, right? So what do you think the solution set's going to look like?
A line.
A line. Good. So the idea is the solution is a line. So points on a line. Now, I've given you sort of the setup over here. How do we express that line? And so let's do that next. All right. So here's how we do this. So what we do is we sort of go down in steps like this. Okay? And so wherever you don't have, so you look at where the pivots are. And if the pivot is not, how do I say this? If the pivot doesn't show up, so for example, then the variable is called free. We'll do some examples. So the variable here that's a free variable is z. Okay. So what we're going to do is we're going to set, did it again. Let's just see if I can push it up. Let's keep it up here. Set z equals t to be a free variable. Okay? And then we're going to back substitute. So then, all right. I'm going to have to work with this weekend. Then back substitute. Okay. All right, so we have these equations. So let's back substitute. So y minus 5 times t is equal to 4. Okay, so remember z is equal to t, so I just plug that in to this equation. So what is y? Y is equal to 4 plus 5t. Okay, so now I have x and I have y. Now I plug it back into this equation up here. So x plus 2 times 4 plus 5t plus t is equal to 0. Oh, sorry, 2t plus minus 7t equals 0. And then when you solve, you get x is equal to minus 8 minus 3t. Okay, so you do the arithmetic. And z is t. Okay? So now let's solve x, y, and z. So the solution, okay, we'll have to, somehow, I don't know if the palm thing is on or off, so I better go check it. So the solution is x, y, and z. And so let's plug those in. So minus 8 minus 3t, y is 4 plus 5t, and z is t. And now what I'll do is I'll separate the t's out. Okay, so I have a t here, and I have a minus 3, 5, and a 1. And then over here I have minus 8, 4, and I believe 0. Okay, and t could be any real number. Boy, it's very sensitive today. I'll have to work with this. Sorry about that. So t is any real number. So as you can see, this is the parametric equation for a line. So this is the parametric equation for a line. Okay, and again, this is singular because there are infinitely many solutions. And there are infinitely many solutions. Okay, so let me ask, are there any questions on this? We'll do more examples on Wednesday. Questions from people on Zoom? Questions from people who are here? Yeah, go ahead.
Did you say T was or wasn't a real number?
Oh, T is a real number. Yeah, so the way you can think about this is that pictorially, you know, when you have a line, a parametric equation for a line, so see if I can draw this correctly. So this is in 3 dimensions, right? Yeah, so it's in 3 dimensions. So your vector 840 looks something like this. So you have a vector out here. Let's see, that's like minus 840. And then you have a direction, right? Namely the minus 351 direction like this. And then you have the equation like that. Okay? So this will give you the line L that you get. Right? So it's pretty neat because you know you have this. The algebra sort of coincides with the geometry that you've seen before. Great. So we'll do more examples on Wednesday, and we really want to make sure we have this algorithm down. Okay. Great. Okay. See you on Wednesday.
Thank you.
Thank you.
Thank you.
Thanks.
Welcome. Oh, I forgot to ask. You stop. Did anyone try out the video at all?
The video?
Yeah, from the class.
Oh, I haven't.
Did anyone try it?
I was about to ask, how are you supposed to access that?
Through Katura. So if people could try it to see if they get it. I'll try to publish this one too. Okay, great.
Thank you. Have a good day.
Okay, you too. Bye-bye.
Thank you.
That's a quick question.
Yeah.